Section 6.2, Factoring Trinomials, Part 1. Alright, so in this section, we're going to talk about how to factor trinomials of the form x squared plus bx plus c. So basically, the lead coefficient, the coefficient on the squared term is 1. Alright, so that's what we're concerned about in this section. Now, before we actually talk about the factoring step, let's see that there is a pattern that we can use. All right, so using the FOIL method, multiplying out these binomials, let's see, we have x by x and x by n. So we would have x squared plus x times n. All right, and then taking the m through, and then we would have plus m times x, and then plus m times n. Now, what I'll have you notice here is that there's a common factor in these terms. There's an x that's in the second and third term. And so if I really wanted to, I could rewrite this as x squared plus m plus n times x plus m times n. I'm sorry, that should have been m plus n times x. So notice that, since these were in like terms, there's nx and mx, by rearranging and factoring out that x from both of them, I could write that as x squared plus m plus n times x. And so for example now, if I had x plus 5 times x plus 7, I can simply write that as x squared plus 5 plus 7, 12x, plus 35, 5 times 7. So I'm just using a pattern here. Now, of course, if you go through all the steps, you'll get the same thing in the end. But what's important is noticing that this pattern, notice how these numbers work. We have an m plus n here, and we have an m times n here. And so that pattern helps us when we're factoring, when we're going in the other direction. So, to factor the trinomial x squared plus bx plus c, we want to find two numbers, m, and let's call them m and n. We want to find these numbers m and n that satisfy their product is c. They multiply together to get the c, the constant, and they add together to get the b, the coefficient on x. And this only works if it's a 1x squared. The lead coefficient is 1, but we find those numbers m and n, and then we can write the polynomial in the factored form x plus m, x plus n. So remember, going from there to there, this is called factoring, because we've written it as a product. So let's see several examples. Factor x squared plus 8x plus 7. Okay, so notice that the lead coefficient is 1. Right, the lead coefficient is 1. So we want to find a pair of numbers that multiply to 7. Well, there's only one pair of numbers that multiplies to 7. 1 times 7. Does it also add to 8? 1 plus 7 equals 8. So therefore, the numbers that we want are m equals 1 and n equals 7. And so what we can then write is that the factored form of x squared plus 8x plus 7 is x plus 1 times x plus 7. And of course we can check this by multiplying it back out. Alright, so let's try another one here. x squared plus 9x plus 14. Again, the lead coefficient is 1. So I want to find a pair of numbers that multiplies. So I'll use that symbol now to mean multiplies to 14. Well, there's a couple of pairs of numbers that do that. We have 1 and 14, 2 and 7. They also need to add to 9. Does one of those pairs also add to 9? Well, the pair that adds to 9 is 2 and 7. So therefore we'll call the m 2 and the n 7, and the factored form would be x plus 2 by x plus 7. Why don't you try the third example on this page on your own? All right, m squared plus 15m plus 36. Again, the lead coefficient is 1. So we look to find a pair of numbers that multiplies to 36. Well, there's several numbers that do that. We have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Is there a pair that also adds to 15? Well, 1 plus 36 is 37, 2 plus 18 is 20, 3 plus 12 is 15. That's the pair that we want. 3 and 12 is 15. So I won't call them m and n because I don't want to confuse with what we already have. But I'll just go ahead and write the factored form as m plus 3 times m plus 12. And again, I could check this by multiplying it back out. What if we wanted to factor y squared minus 12y plus 27? All right, so we need a pair of numbers that multiplies to 27. Again, notice that the lead coefficient is 1. Well, there's 1 and 27 and 3 and 9. We also need them to add to negative 12. Now wait a second, 1 plus 27 is 28 and 3 plus 9 is 12, not negative 12. So here we have to be careful. A negative times a negative is also positive. Negative 1 times negative 27 is positive 27, but they sum to negative 28. Negative 3 and negative 9 multiply to positive 27, and negative 3 plus negative 9 is negative 12. That's the pair that I want. So then I would write the factored form as y minus 3, y minus 9. We don't write plus and negative, we just write minus. All right, what if we had z squared minus 15z minus 54? So again, notice that it's a 1z squared. So finding a pair of numbers that multiplies to negative 54. Now, wait a second, it multiplies to a negative. The only way you get a negative product is if you have different signs. So we could have 1 and 54, 2 and 27, 3 and 18, 4 doesn't work, 5 doesn't work, 6 and 9. Now, remember also that if you're adding with different signs, you actually subtract and keep the sign of the larger. So the only way I can get a 15 out of this would be using the 3 and the 18. But now I have to be careful of the signs. I need a negative 15. So I would want a positive 3 and a negative 15 because and a negative 18 because positive 3 plus a negative 18 gives me a negative 15. So the pair of numbers that I want is positive 3 and negative 18. and I would write the factored form as z plus 3, z minus 18. Right, let's look at another one here. R squared plus 4r minus 6d. Again, notice that the lead coefficient is 1. So I want a pair of numbers that multiplies to negative 6d and adds to positive 4. The pair of numbers that multiplies to negative 60, well, let's just focus on the 60. We have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, and that's it. And I wrote an 18, sorry about that, 6 and 10. All right, so now let's see. I know that they have different signs. Since it multiplies to a negative 60, I have different signs. All right, so let's see. Since I have different signs, when you add numbers with different signs, you really subtract. Keep the sign of the larger. So 1 and 60, 59. 2 and 30, 28. 3 and 20, 17. 4 and 15, 11. 5 and 12, 7. 6 and 10, 4. 6 and 10 have a difference of 4. So I need this pair of numbers. Now let's get the signs right. I need a positive 4, so I'll use a negative 6 and a positive 10. Negative 6 plus 10 is positive 4. So negative 6, positive 10, and I would write the factored form as r minus 6 times r plus 10. All right, so here are several that I would like for you to try on your own. Now would be a great time to pause. B squared minus b minus 12. All right, again, notice the lead coefficient is 1. So I need to find a pair of numbers that multiplies to negative 12 and adds to negative 1. Finding the factors of 12. 1 and 12, 2 and 6, 3 and 4. Now, I need them to have a difference of 1. Again, notice since it's a negative product, I need a difference. 1 and 12 have a difference of 11. 2 and 6 a difference of 4. 3 and 4 have a difference of 1. That's the pair that I want. Now getting the sign right, I need a negative 1. So I'll need a positive 3 and a negative 4, and those sum to negative 1. So I would write this in factored form as b plus 3 times b minus 4. All right, a squared plus 13a minus 42. Again, the lead coefficient is 1. So I need a pair of numbers that multiplies to negative 42 and sum to 13. 42, the factors of 42 are 1 and 42, 2 and 21, 3 and 14, 6 and 7. Now, I need a sum of 13. But now wait a second, I have different signs. All right, since they have a negative product, I need different signs, so I really need a difference. 1 and 42 would give me a difference of 41. 2 and 21 would give me a difference of 19. 3 and 14 would give me a difference of 11. And 6 and 7 would give me a difference of 1. Nothing works. When this happens, what we will write is that this is a prime polynomial. Okay, and what this tells us is it cannot be factored at this point. If you were to take maybe a pre-calculus course, you would learn how to factor this polynomial. All right, and y squared minus 10y minus 39. All right, again, lead coefficient is 1. So we want to find a pair of numbers that multiplies to negative 39 and adds to negative 10. So finding the factor pairs of 39, we have 1 and 39, 3 and 13, and that's it. Since I have a negative product, I have different signs, I'll find a difference. 38 and 10, that's the one that I want. Now getting the signs right, if I had a positive 3 and a negative 13, positive 3 plus negative 13 is negative 10. So I would factor this as y plus 3, y minus 13. All right, now let's say we had to factor 2x squared plus 8x minus 10. Now, right off the bat, we should notice that the lead coefficient is not 1. And so we might say, well, we don't know how to do this yet. But we have other methods that we learned in the previous section. 2x squared plus 8x minus 10, these are all divisible by 2. In fact, the greatest common factor is 2. So I can write this as 2 times x squared plus 4x minus 5. Now I'll focus on factoring the trinomial, because now that trinomial has a lead coefficient of 1. So I need a pair of numbers that multiplies to negative 5 and adds to positive 4. The only factor pair for 5 is 1 and 5. And focusing on the signs, since I have different signs, these do have a difference of 4. And I need a positive 4, so I'll take a negative 1 and a positive 5. Negative 1 plus 5 is positive 4. So then what I would write is that the completely factored form would be 2 times x minus 1 times x plus 5. Why don't you try the other two on this slide on your own? Now would be a good time to pause. All right, z cubed plus 9z squared plus 20z. These have a GCF of z. So I would write this as z by z squared plus 9z plus 20. Now there's a lead coefficient of 1 on the trinomial. So I'll find a pair of numbers that multiplies to 20 and adds to 9. The factor pairs for 20 are 1 and 20, 2 and 10, 4 and 5. Since it's a positive 20, finding the sums, 1 plus 20 is 21, 2 plus 10 is 12, 4 plus 5 is 9, 4 and 5 is the pair of numbers I want, and both positive, as the sign on the second term is positive. So I would write the completely factored form as z by z plus 4 by z plus 5. And 6n to the fourth minus 18n cubed plus 12n squared. Let's see, the lead coefficient there, the GCF is 6n squared. So I'll write this as 6n squared times n squared minus 3n plus 2. Now the lead coefficient is 1, so I'll find a pair of numbers that multiplies to 2 and adds to negative 3. Alright, so the only pair of numbers that multiplies to 2 is 1 and 2. We need that pair to also add to negative 3. Well, I could have a negative 1 and a negative 2. And a negative 1 times negative 2 is positive 2. And negative 1 plus negative 2 is negative 3. Alright, so that works. So then I would write the completely factored form as 6n squared times n minus 1 times n minus 2. All right, factoring a little bit more here. Let's say we had 3 minus 4x plus x squared, and we're asked to factor it completely. Well, this isn't in a form that we like. It's just, not what we're used to. So let's write it in that descending order that we talked about in the previous chapter. 3 minus 4x plus x squared can be rewritten in descending order as x squared minus 4x plus 3. Right, because this was a positive 3. And so just keep the right sign with the right term. All right, now the lead coefficient on the x squared is 1. So we want to find a pair of numbers that multiplies to 3 and adds to negative 4. And let's see, the only factor pair for 3 is 1 and 3. And if they are both negative, a negative times a negative, positive 3, and negative 1 plus negative 3 is negative 4. So then the factored form would be x minus 1 by x minus 3. Now, let's say we had 28 plus 3x minus x squared. Rewriting that in descending order, we would have negative x squared plus 3x plus 28. Now this one's a little different than the previous because now we have a lead coefficient of negative 1. So what I'm going to do is I'm going to factor the negative 1 out. So I'm going to rewrite this as negative 1 times, so basically I'm thinking of the GCF as being a negative 1. So I'd have negative 1 times x squared minus 3x minus 28. All right, now I have a lead coefficient of positive 1 on the trinomial. So I want to find a pair of numbers that multiplies to negative 28 and adds to negative 3. Now, since we're multiplying to a negative number, that means I need different signs. Looking for the factor pairs of 28, I'd have 1 and 28, 4 and 7. Well, finding a difference, since I know I'm going to have different signs, these give me a difference of 27, and the 4 and 7 gives me a difference of 3. So that's the pair that I want, and since I want a negative 3, I'll choose positive 4 and negative 7. So the factored form, completely factored, would be negative 1 times x plus 4 times x minus 7. Why don't you try this last one on your own? All right. Using a similar idea as the previous one, let me write it in descending order as negative x squared minus 3x plus 40. And again, I see the lead coefficient is not 1, but negative 1. So I'll rewrite this as negative 1 by x squared plus 3x minus 40. All right, now my lead coefficient on the trinomial is a 1. So let me find a pair of numbers that multiplies to negative 40 and adds to 3. Running through my factor pairs for 40, I have 1 and 40, 2 and 20, 4 and 10, 5 and 8. Since I have different signs, I'll take a difference. Let's see, 39, 18, 6, and 3. That's the pair I want, the last one. And so then let's get the signs right. I need a positive 3 here, so I'll take a negative 5 and a positive 8. So then the completely factored form would be negative 1 by x minus 5 by x plus 8. And we'll finish off the section with an application. A rectangle has an area of x squared plus 9x plus 8. Find one possibility for its width and its length. Alright, so rectangle has area. Alright, so remember that the area of a rectangle is simply its length times its width. So we want the length times width to be x squared plus 9x plus 8. So we want to find two things that multiply together to get x squared plus 9x plus 8. We need the factored form. So then x squared plus 9x plus 8. Well, notice that the lead coefficient is 1. So let's find a pair of numbers that multiplies to 8 and adds to 9. Running through your factors of 8, we have 1 and 8, and 2 and 4, and the only pair that sums to 9 is 1 and 8. So we can write this in factored form as x plus 1 by x plus 8. And so one possibility would be that the width is x plus 1, and the length is x plus 8. The other possibility would to have these with the length first. The length is x plus 1, and the width is x plus 8.